So by now you have heard that if we have vertex form of a quadratic, the vertex is negative hk. Some people will say it's hk. I'll describe why I call it negative hk later. Why does that work? That's a nice little rule we have there, negative hk, nice and fancy from here, but why does that work in this form? Well, to think about that, we have to look at the parent function. What is the parent function? The parent function is y equals x squared. If I want to write it in vertex form, then I will have y equals 1 times the quantity x minus 0 squared plus 0. That's the same as this because I can multiply by 1, subtract 0, and add 0. None of that stuff changes it. Those are all identity properties. So I just wrote it like this so that I can see a is 1, h is 0, and k is 0. So let's look at that parent function on a graph. We can see that if k is 0 and h is 0, then your vertex is going to be 0. Okay, so let's look first at k. K tells us that that is the y point of your vertex, so that's going to be up and down. So if we stay on the x-axis, then x has to be 0. So let's look at what we can do with that. So if x equals 0, and we're on the y-axis, and we know h equals 0, because we're not going to move from that. 0 minus 0 is just 0. So this whole thing goes away. And we're left with whatever k is. So that's kind of an easy explanation there, because now y equals k. So whatever k is whatever y is. We can see that. As we change k, that's what y is. K is 4, y is 4. K is 0, y is 0. K is negative 2, y is negative 2. It changes with it. Now h is a little bit more difficult to understand, but we're going to look at it. So h, we know this is going to move it back and forth, left and right. So in order to look at h, we're going to stay on the x-axis. Just like when we were looking at k, we stayed on the y-axis just to look at it, because that's going to make everything easier. It's going to make everything easier because that means k has to be 0. We know that k moves it up and down. So if we want to stay on the x-axis, k has to be 0. So now we can look at it and not have to worry about k. We can just think y equals x minus h squared. I'm not worrying about a either because we're keeping that 1. So anything multiplied by 1 is itself. So let's just look straight at this then. So if we're staying on the x-axis, what does y have to be? Y has to be 0. This is the line y equals 0. That's the x-axis. So if we're staying with that, then we know y is 0, which means x minus h squared has to be 0. Well, how can this be 0? A quantity squared, the only thing squared that equals 0 is 0, which means x minus h has to be 0. So, how can x minus h equal 0? Well, that's easy. If x is h, we can have 3 minus 3 equals 0. We can have 4 minus 4 equals 0. We can have negative 5 minus negative 5 equals 0. Anything subtracted by itself is going to be 0. So that means x has to equal h. And we can see that. Whatever I make h is what x is going to be. follows it along. I can do my 3 examples there. 3 equals 3. 4 equals 4. -5 equals -5. Wherever you go with h, since y has to equal 0, then that's what x has to be. I can hear some of you grumbling and saying, wait, in the beginning you said that x was -h, and here you're saying x is h. X minus h has to be 0, so x equals h. So why did you say in the beginning x is -h? Well, that is an explanation for the end of the video, so I will get to that. I just wanted to mention that to make sure that you know I will talk about that. So we see that works when we're stuck on the x-axis here and y has to be 0. What about if we're somewhere else, though? Does it continue to work? Well, let's try changing k to 3, and then we'll slide h around. Is it going to work? Yes, it looks like we're stuck where y equals 3. Well, that happens because wherever this whole thing equals 0, then y is going to be k. Well, where does this equal 0? We just talked about that. That's going to be 0 when x minus h is 0. So that's when x equals h. So y is going to be k whenever x equals h, which means hk for our vertex. Now I'll take the time and explain why I say -hk for the vertex. In order to see why I call the vertex -hk, when all that math we just did seems to point at it being hk, and you'll even see this around. The reason I say -hk instead is because I like to emphasize that every number has its sign, is either positive or negative. In this case, this is a +3. In this case, a -4. In this case, a +5. So, if you were thinking hk for this, then you would say -4, +5. But that is incorrect because that negative is part of the equation. So I like to say -hk because we should have a -4 here. The opposite of -4 is 4, 5, which is the correct vertex. In this case, this is a -2 for A, a +3 for H, and a -10 for K. So if you want to say -hk, see, some might say, if this is hk, okay, 3, maybe you'd even say -10 there, because it looks like +3 right here, right? Well, that is the wrong vertex. Since the formula has a negative in it, this is -h. Okay, will be the correct vertex. Again, one more time. +4 for A, +10 for H, and +11. The correct vertex is -10, +11. That is why I say -hk instead of hk, so we don't get confused.